parking. That parking becomes a structure, and then you start putting the landscape on top of these projects. What I'm taking up is like one small fraction of podium landscape architecture, where there's a multi-layered discussion that can happen on podium landscapes. I'm just talking about what you do or how you handle water and how that impacts some of the levels that you have in the podium landscapes. And it's just going to be this part. I'm going to try and keep it as non-technical as possible. Um, and I'm just going to try to explain to you conceptually what we do with how we handle water and how that impacts the levels on site. And I'll probably do this a little quickly in the interest of time. But if you have any questions, I mean, maybe we'll have an extended question answer session. So this is a project we did a while back. It got held up in the middle, then it started again, got completed around the turn just before COVID started. And I haven't been to the site since COVID, but this is somewhere in Thane. This is one of those very simple projects where they have they have two residential towers. A third one is coming up. They have what you're looking at in the center is the parking structure with a small clubhouse on the side. And they had asked for a very, very simple, straightforward design, and we delivered just that. So what you're looking at, and this is good for us in terms of simplicity, because it makes it easier to understand what the complexity of drainage management is. So in the structure in the center, you have a small patch of a straight patch of lawn and a straight patch of plant of paving, divided by planters for trees. On the other side, we will have a small seating, and then there's this interesting interconnection between the car park on the right hand side, where they did not allow us to do any kind of landscaping on top, with the car parking on the left hand side, which is more green and has these planters for trees. So on the left hand side, this is the terrace as you would know it. If you see the left hand top photograph, you will see on the right hand side there are these small holes in the walls. That's where the water comes out from. And since they did not allow us to do anything, we said, okay, at least with the China mosaic, just get 50% black and white, and we'll tell you something that you can do. And that's about, I mean, essentially this is a terrace where absolutely no design has happened. But the other parking structure, the structure that we saw on the left hand side with the clubhouse at the back, they presented us with a slab where the waterproofing brickbat coba had already been done. And this is a situation we come across. It's a massive complication in the construction of things, but that's something we will talk about in the end. But what you're essentially looking at is the ridges that have been made over here are the ridges made for holding water, so that they're curing the cement finish on top of the water brickbat coba that they've done. You can see the curve along the edge. And now I'm on page number 10, where we are looking at the construction process. What I want you to pay attention to especially is this large drop on the left-hand side, where you're seeing a drop down and a large drop on the right-hand side. So you're essentially seeing that with construction work, with masonry work, we've actually built it up. And this will quickly relate you back and forth to the design, where the lawn has now come up to the level of the ground. I mean, the part of the ground that was built up. So I'm going to go back to the previous image, and there are people standing on the left hand side, and there are people standing on the planter, and you're seeing the part of the left hand side which was paving built up, and then the center which was lawn is in a depression of sorts. And I'm going to take you through how that I mean, why that depression is there and what is the logic for it. So you're now looking at page 12, where you're looking at a line out plan, and these are some of the basic drawings that sort of tend to go on site. You're looking at a line out plan. You're looking at a grading plan. A grading plan is just a plan of all the levels of the site, and these are just the surface levels. But the most important plan is usually the next plan, which is called the subsurface plan. The subsurface plan, subsurface means below the surface. So you're actually looking at all the walls and all the construction work that's happening just below the surface. So I mean, if you took a look at this where it says channel drainage. Can you see my mouse moving? And just a quick check. Are you all with me so far? Anyone?
Yes, we can.
Okay.
We can see it.
Okay, so here where it says channel drainage, you're seeing two walls over here. If you see it on the grading plan, you don't see those two walls. So it becomes automatically important to understand why those walls are there. And what I'm going to do now is there's a lot of information that's on this plan. Okay, and I'm going to break down that information conceptually in terms of a color diagram. And I'm going to explain to you what happens where. Okay, so my labeling is at the bottom now. It says columns under location of the podiums, column location under the podium. So these purple squares are the columns under the podium. We don't see them over the podium, but they're definitely there underneath it. The reason we need to know the locations of these podiums, because many times those are the only places where we can locate trees, because the structural consultant hasn't accounted for any tree on this podium anyway. So they end up deciding the location of the trees. But the other thing that structural consultants do sometimes, or civil contractors do, is they start putting that downtake pipes, which are marked in red, right next to the column. And this is really important, because a downtake pipe, as you would study in your working drawings or services, is the pipe that takes water from your bathroom, let's say, and takes it by a pipe in a downward direction. So this is where essentially all our storm water, which is rainwater, has to go to for it to be taken away from this slab. So that's kind of important, and that plays a role, as you will see. The next slide I'm looking at is the brick wall slide. So everything that I've marked in red are all the brick walls that happen on site. And I'll start relating it back to some of the photographs a little later on. But you're essentially looking at the planter brick wall for the trees. So there are these 4 trees. You are looking at a planter brick wall for a channel that was made over here. You're looking at a planter brick wall for a planter on this side. And then there was a seat with a little bit of masonry in front. Now, I'll be pointing all of these things out to you later as the photographs progress, but just keep this in mind for now. The next image you're seeing is, let me see if I can move this. Okay, I can't. So you're looking at the waterproofing, the brown surface that is been colored. That is the filling for the paving. Now, in this project, the filling was done in masonry work and C4X work, and that's a very different conversation, because how waterproofing is done is something I want to talk about right in the end. But for now, this is just the filling work done for the paving area to bring the paving level to where the lawn will be after the end of the project. And this will make sense when I show you the sections. And in green, I am indicating, in light green, I'm indicating where this filling for the soil is. And in dark green, I'm indicating where the filling for the tree and the shrubs are. Okay. So we are now going to look at it in section. On the right-hand side, we have the plan. On the right-hand side, we have the plan. And you're looking at 2 cross sections on the plan. The section that is taken on the right hand side through the tree planter is seen above, and the section where you see the tree planter in elevation is seen below. I'm sorry that the okay, I can move it. Fantastic. All right. Okay, so I'll quickly start coloring it in exactly the same way I'd shown it to you in plan. So we're seeing a red masonry work that I had shown you over here. So you're seeing the red masonry work for the planter, and you're seeing the red masonry work for on the left-hand side for the seats and for the walls at the bottom. You're now looking at the lightweight filling and waterproofing. So you're seeing on the right-hand side, you see the lightweight filling for the flooring is a little higher. And then there is some filling. You see some filling under the lawn area as well. That's essentially happening for the leveling of the bottom surface of the lawn, which also then again has to be re-waterproof. So that's something I will explain to you very soon. And the green color you're looking at right now, you're looking at the light green for the thickness of the soil for lawn, and the thickness of the soil for the tree area and the shrub area that you see at the bottom. All right. So let me just quickly go over this. You saw the red color in red color for brickwork, the brown was the filling, and the green was the filling for the soil. You see that immediately in the cross section as well. You see red for the brickwork, for the planter and the seating. You see the brown for the filling, and you see the green for the soil. Okay, so now how does all of this work? Let's talk about a rainy situation where it's actually raining. What you have to know is that there is this orange line that I have marked right now. This can be this is the waterproofing line for this project. So ideally speaking, we don't want water to go anywhere below this line. So essentially what's going to happen is that the soil water penetrates into the soil. That happens. You have the flooring on the right hand side, but water can sometimes go through the cracks in the flooring depending on the workmanship. So below that, ideally we need this waterproofing layer, at which point it will then, even if it goes through the flooring, it will hit that point and then move sideways. There are a few exceptions to this, what I'm saying, which is why I'm using the word ideally, but that's something I want to cover right in the end. Now, what happens is when it rains, if you see what's happening on top of the lawn is you're seeing almost half the water travel along the surface of the lawn, that is the top portion of the lawn, and on the right hand side you're seeing most of the water travel over the surface of the flooring. And what you're also seeing is that half of the water approximately is seeping into that soil. So the water from the top of the soil and the top of the flooring is now traveling towards the channel that we built over here, where it says 225 depth. It's traveling towards this channel, and this channel is going to lead ahead. So all right, so that's part one. Part two is the subsurface drainage. That means what happens is that sometimes the soil takes in a lot of water. It takes in more water than it needs, and that water needs to be let go. So what will happen is that the water will touch the waterproofing part of the surface, and it will slope towards the channel that you see on the right hand side. Which is why we do have filling under the lawn, where the lawn is meant to slope towards that particular drain. If you notice, and I should have probably mentioned this last time, I mean, not last time, I mean, in the previous slide, is that the flooring also is sloping towards the drain, but it's not sloping in a way that is easily visible or easily noticeable. It's sloping somewhere in the range of somewhere between 1:50 and 1:100. For your information, 1:50, you kind of get a sense of the slope, but it's walkable. 1:100 is like a bathroom slope. But the important takeaway over here is every surface out in the open, which is under the rain, which is going to receive rainfall, has to be sloped so that the water can flow towards a channel. So you have this happening, and then from the channel, the water is then directed to the downtake pipe via pipes, and then from the downtake pipe, there's a downward arrow that takes it down. And there are methods of having a combination of perforated pipes and full pipes that'll collect the water and then take it down. So we're going to see this exact same thing in plan, where if you remember, the first line was the purple line, which is and because the flooring and the lawn itself is sloped towards the channel, you're seeing the water slope towards this particular channel and then enter through the holes into this channel. You're then seeing the subsurface. This is the water that seeped into the soil and reached the bottom surface. It is sloping in the direction that we've sloped it. So it's going to these 3 points along the channel wall where it enters holes, or I mean, it enters. We make holes in the walls over there, so it enters the channels at those points. On the top, you're seeing that the planter over here, there is a hole that connects directly to the downtake pipe. So this is pretty quick. Over here, it has to enter the channel, then go through the pipes to this downtake pipe and then come down. And in this image where you're seeing the red arrows, you're looking at the water entering the channel, it traveling inside the channel, and then through piping, it goes towards the downtake pipe, and then it travels downwards. So that's what this entire plan is conveying. It's conveying what's happening at the subsurface level. If you notice, I'm just showing you a zoom in of this area. If you notice, I have FG written, which means finished surface of the ground. And you will see that in the FG, you sort of notice a slope going downwards. That's not what this arrow is indicating. This arrow is indicating SS, which means subsurface level. The subsurface level is the level which I mentioned was the orange dotted orange line. Let me just go back to it. You see this orange line over here. That level was called the subsurface level. So so the dotted lines are indicating what's happening with the subsurface level, and the subsurface level also shows that there is a slope coming towards this particular corner. Whereas on the right hand side, which is just the grading drawing, I'm only indicating what the surface levels are. So this FG and this FG should ideally match, and it is matching. But and on the right hand side, you're seeing the slope down going straight towards the channels on top. So the slope on the surface of the lawn is a little different than the slope on the bottom, on the subsurface portion, because the subsurface has to drain towards a different kind of a inlet, while the surface portion, so the surface of the lawn has to drain towards this the holes in the channel. So now I'm going to show you photographs of the construction on the site taking place. Keep the channel and the levels and the brickwork in mind, and that will it'll help you sort of relate to what's happening. Just give me a second. Hang on.
Okay.
All right.
Thank you.
Yeah. Okay, sorry about that. Okay, so you're looking at the construction photograph. This is the same photograph I showed right in the beginning. I'm now going to show you a few details of this. Let's look at the right side first. This C over here was the C in construction, in brickwork that you saw. And then you saw some filling happening in the seat itself. So what we're essentially doing is you're seeing the C4X work at the bottom. This we are bringing to the level of the soil that will happen. This thickness we need for the soil depth, because we need that much soil for the for the waterproofing and the slope of the lawn, and for the lawn itself, of course. What you're seeing over here is the wall, and inside that wall we'll be filling it with soil again, which will have shrubs in it. On the left hand side, you're seeing this cross section where I mean, you're seeing 2 feet. You're seeing me step over over this drainage that you see on the right hand side. The left hand side seems, if you're paying, I mean, if you're observant, you might notice that the left hand side is a little lower than what's happening on the right, on this side of the brick wall. That's essentially happening because we have C4X on the left hand side, and that's going to be waterproofed again on top. The industry standard for waterproofing C4X is a PCC slab on top, so that's a very different conversation. But I'm just sort of letting you know that as a separate Vishesh Tipni. And behind, you're seeing the civil work for the planter. So you're seeing the main planter box, where we need trees to have at least 4 feet of depth of soil so that they grow well. And then at the bottom, you're seeing the brickwork for seating, so that you're sort of breaking down the verticality of the planter in 2 parts. Okay, so in the previous photograph, we saw the civil masonry work happening. What you're now looking at is a lot of the waterproofing work happening. You'll see the vata being made at the other corner. So now in this waterproofing, the ground, I mean, the surface is being sloped upwards towards the seat and the seating area. And you're then seeing the vata on the corner. The holes that you're seeing over here, those are left for electrical fixtures. They are not, I mean, they're not left for electrical fixtures. They're actually left for the construction of the steel work. And that's a different thing. It has nothing to do with the stormwater drainage. It's a separate technicality. And this is the waterproofing underway on site. So what you're seeing is, from further away, you're going to see the subsurface water come towards here. Here they've put the stone on top of the channel, and then they're going to make holes on it. And this is somewhere close to the finished product, where the lawn will be sloping towards the channel. You're seeing the channel over here with the holes on it. So the water will flow towards the channel, and then the water that seeps underneath will also flow towards the channel and enter it through another inlet. So this is what it will look post planting. But what's important to get is when you're sort of seeing, when you're seeing these two photographs, it's important for you to conceptually understand what the engineering is, under the surface, because it's really important to get a sense of, what sort of slopes are required, what happens when the water enters in, what happens, how does that water travel, what does it do. And essentially you see that the slab is that dark gray portion, and essentially the level of the landscape, because we wanted that lawn over there, actually went up much higher, and this is about 1.5 feet higher than the people who were designing this would have anticipated. And this is simply because of the requirements of stormwater drainage. Now you may have noticed that there is this gray layer also, and that's something I will talk about in the end, but this is a complication that I don't want to dwell on too much right now. So we will just talk about it as we progress. We are now at the absolute end of this presentation. I just want to show you a couple of products that are important for this kind of stormwater drainage project. If you saw the section I had on the left hand side, this is the detail of that section. The first thing I want to show you, I'm pointing out, if you see the section, I'm pointing out not at the purple line, but I'm pointing at the gap between the purple line and the green line over here. And that is what we've done over there, is we've created this gap so that the water can flow more quickly. If you imagine water flowing through soil, it is obviously obstructed many times and the water has a lot of difficulty to flow. So it's a good idea to create this gap between the soil and the surface, and that is created by two wonderful products called the drain cell and the geofabric membrane. What happens is when you create this gap, the water flows out much more quickly and then it enters the channel much more quicker. So if you imagine this right hand bottom cross section, you have the growing soil, and then under that you'll have a geofabric membrane and then the drain cell. So the water will go through the soil, through the geofabric membrane, enter this drain cell area. It doesn't go any lower because then you have the concrete slab and the waterproofing on top of it. And then through this drain cell, it just travels straight across towards this channel. Notice that even at the subsurface and at the surface level, you are seeing this slope towards the channel. The next product is this green line that I have made in the section, and that is that geofabric membrane. This is sort of like the detail of geofabric membrane. And the description or the explanation for this geofabric membrane is best given by Sandeep when 2 years ago he was explaining to a student that a geofabric membrane is a rumal that you have so that it prevents the soil from falling off, but it allows the water to go through. And I think that's a description that even I have stuck to for the past 2 years. It's geofabric membrane is a rumal. So you have a drain cell, you put a rumal on top, and then you put the soil on top, and then you're sorted, and that's how the water drains out. Okay, now here is the slight complication in this particular project. In this particular project, what had happened was that when we saw the podium had been built for about 3-4 months, and when they brought us to the podium, they said, the brickbat coba is already done, now you can do whatever you want to. And this is a problem because when the waterproofing of a site is done without having the landscape architect on board, what happens is that they automatically just slope it towards the outlets. And then that prevents us from putting walls in the middle. And then we invariably have to tell them that, look, the water is not going to flow like this. It's going to have to flow very differently because we're putting these planter walls in the middle. So we are probably have to going to redo the sloping of the site. And then that's a different conversation that we end up having with the builders, with the contractors, with the client. But what I want to just bring to your notice in this photograph was there is a layer of brickbat coba, and the brickbat coba then looks like this on the right hand side. Whereas on the photographs that I showed you was an additional layer of waterproofing that was actually done with chemical waterproofing and cement screening. So it was essentially just cement, mortar, and it's mixed with chemicals, and then that's used as a chemical, and then there's a coat given on top of it. So that's chemical waterproofing that you're seeing on the right hand top side. The brickbat coba is a different system of waterproofing. where the conversation that surrounding that becomes even is entirely different. Um, but I mean, I just wanted to bring that to your notice, and if you want to ask questions about it, feel free to. Uh, I honestly don't remember why I put these two slides in here. I think the point I was trying to make was the brickbat Koba you're seeing over here is from another project, but what I was trying to say was when the project is complicated, the waterproofing and the stormwater drain management system also becomes equally complicated, and it's really important to have a sense of what's happening. And this is the last slide, the last thing I want to talk to you about is what this filling is under the flooring. In our project, I think I made a mistake over here. I've written that what's happening on our site is brickwork. It's not. What's happening on our site is C4X work. Traditional method would have been a brickwork masonry, but nowadays brickwork is used very sparingly because brick is one of the heaviest objects there are. So every structural consultant will always say, use a lighter material if possible. So the traditional method is brickwork, except that this is not brickwork. You're looking at the C4X blocks. It's gray over here. One of the latest materials to come in the market right now is called Modi foam. It's a very compact styrofoam sort of material, which does not react with anything. It absorbs very, very little water. It's extremely lightweight, and it comes in different thicknesses. So you can lay them on the ground as you want to, and then you do the flooring on top of that. A point to note, and this is something you'll probably learn in the future, is that each of these traditional methods have a very different waterproofing system. So Modi foam would have to be waterproofed at the bottom. Brickbat Koba, the more we hear about it, the more contractors are telling us that no, we only do the waterproofing at the bottom. On top, we only have the flooring, and the bricks in the brickbat Koba will absorb water, which is a big problem for us because what we learned in college was that when you do a bathroom brickbat Koba, the waterproofing is on top because there is chemical mixture in the top layer of the brickbat Koba. In C4X, you have to have and what you're seeing over here is that you have this PCC layer on top of the C4X, and that PCC layer becomes the waterproofing layer for the C4X blocks. And the reason you don't want water to touch the C4X block is that C4X blocks have a tendency to absorb only a little amount of water. They're a little lightweight, a little porous, but they are likely to catch a lot of algae and a lot of rot because it absorbs that level of water. So, I mean, this is just something I wanted to mention very, very briefly, but just to give you an understanding of what sort of filling materials are used in projects like these. That brings me to a quick end to this long presentation. And the reason I've done that is that I think it'll be a good idea for you all to ask questions and then extend this lecture time by another 15 minutes. If there's anything you haven't understood, I know I've gone fast a little bit on purpose. If you have any questions, please feel free to ask, and I will repeat myself for this presentation. Yeah. Was I audible all this time?
Yes, you were, Arjun, and good presentation.
All right. Would anyone in the audience like to ask anything?
So I just wanted to ask that
Yeah.
gray layer, the light gray layer that we see is the
Yeah.
BBC, right?
Yeah. Brickbat Koba. Yeah.
So if in case that was not there earlier,
Yeah.
if it was not put by the builder, then you could have like put soil over there and increase the soil ka layer.
No. Essentially, that entire layer would disappear and the whole thing would come down.
Okay.
Okay. So this has become a fully redundant layer in this cross section.
Okay. Okay.
And that's it's not a nice thing to tell the client that, look, I know you've done the waterproofing layer, but it's not working for the design that we will do for this project. And this becomes a slightly difficult conversation with the client, but then they realize that we can still salvage this operation. It's not going to be too much of a problem. But it's important to know that this entire layer is fully redundant in this cross section.
Right.
Right.
Like another thing I'm wondering is that like this layer of soil that has been put, it looks to be
Yeah.
like roughly 200 mm, right?
The drain cell,
This soil ka layer.
the soil color, yeah, it's
Yeah.
in this project, it's about 210. So soil lawn grows wherever it can. The thing is, the amount of soil a lawn has is fully proportional to the amount of nutrition that lawn gets. All right.
Mm.
Now, I mean, you can grow lawn in 100 of soil, but the ideal condition is usually, I mean, for the office that I came from, the ideal condition was always set at 300 millimeters of soil. And where we don't, and depending on the problems that we have on site, we would reduce the amount of soil and say, look, we are reducing the amount of soil, but then you will have to irrigate it more, and not irrigate it more, but you'll have to manure it and give more fertilizer from time to time, essentially because the lesser amount of soil means the lesser amount of nutrition the soil is, the lawn is getting. So to answer your question, this is 225 approximately thickness of soil. You can grow a lawn in 100 but it is not ideal. The ideal condition is 300 of soil.
Yes, actually, what I was coming to was that
Oh,
like 200 seems a little less because
yeah,
over
it is.
time it'll like erode and like it's the
It won't. Okay, so projects of this sort, well, will it erode? Yeah, you're probably right. It probably won't erode because of wind and rain. It'll erode probably because of water taking it away through the drainage system. And these kind of projects, podium projects especially, maintenance of the landscape becomes an important component, which would also include, maintaining the level and the amount of soil that is there in this project. So erosion is not that big a problem, but yes, some amount of soil will be lost, and that will be made up for by the annual maintenance contract that we will do for this project. That will ideally be done for this project.
okay. Yeah.
Okay. Anyone else? Any other question?
I just had a like unrelated question. What happens when
Sure.
you're doing such kind of landscaping on the on ground level when you don't have like a BBC layer or anything?
No,
Do you like raise the level of the entire ground or something?
no. You most of the times you would probably dig in, but yeah, see what would happen in areas like Bombay and Thane. The standard practice over here is to bring in soil from elsewhere, which is red soil, which we call sweet soil, and it's mixed with manure. So the landscape architect will then take a decision whether he wants to maintain the existing level on site or whether he wants to do the filling on site and allow the level to increase by a foot. Over there, and it really depends on how it relates to the rest of the ground and how it relates to the architecture. But we have a lot more flexibility in what we want to do with the level and where we want the level to be. And sometimes we dig in and sometimes we allow it to rise up. It's completely up to us.
Okay.
Hello.
Yeah,
Yeah, I have a question related to the placement of trees. Like,
sure.
what depth do we need there, like, to place a tree, and why it is important to place a tree below the, like, above the columns, and what?
Hmm.
Uh,
Okay, so this is what I have experienced in my practice. The first is structural consultants very rarely account for a large tree located on their slab. Okay, on the slab. So if you think about a podium structure, the base structure, let's divide it into the slab, the beam, and the column. So very rarely do they account for a tree being placed on the slab directly. They will say if they do not design for a tree being located on the podium, they usually do not object to the tree being placed on the column or away from the column, because the column can take that much, column has that much redundancy to take that kind of load. Okay. If you know beforehand that you are going to place trees on site, you can tell the structural consultant, look, we're going to have trees. The trees are not going to be located on the columns. This is the location of the tree. Please design accordingly. And then it is theoretically possible for the structural consultant to design for those kind of tree loads. In this particular project, the car park was already done. They built the car park. They did the waterproofing on the slab, and then they started looking for the landscape architect. And the first thing we asked, are you comfortable with trees? And they said, no, we're not. So I said, all right, then let me speak to the structural consultant. He may be comfortable with locating trees on the column. And I thought that was nice in the sense that at first I was going to locate 5 trees. You can imagine that there's a tree in the middle missing, which really bugged me. But they were very adamant about having a kids play area. So I had to remove that one last tree. But I would have loved this idea of having this very linear sort of design where you have a strip of lawn, a strip of trees, a strip of paving. And essentially these trees would then be located only on top of the column. And then the structural consultant says, yeah, if it's on top of the column, that's fine. But if you notice this a little more carefully, let me just come to that page. The last 2 trees, the trees on the right, leftmost and rightmost side, they're not on top of the column. They're actually a little off it, but they're very close to the column, and they're on top of the beam that connects to the column. So this was also another conversation we had with the structural consultant. The last column is going to be a little off it. It's going to be very close to the column. Don't worry about it. It's just going to be on. It's going to be on the beam for sure. And then that's another conversation we had. So, I mean, if you guys know your theory of structures, you'll get a sense of the slab being designed for the least load and the column being designed for the most load on the slab, and as far as the live loads and dead loads are concerned. And that's essentially some of the logic we have to take into where we can locate trees and where we cannot locate trees. But if you have the opportunity to locate trees before the slab is being designed, you're very, very lucky. I mean, then it's good for you. Then you can design for that to happen. Does that answer your question?
Yeah.
And any other question about drainage of water? Okay, any other question about anything else?
Are we selective about the larger trees we plant over here because of the roots and the extent of?
That's a good question. Yeah. I generally, okay. So an important thing to remember, that a tree will only grow as tall as the roots allow it to grow. Okay. So that's one thing to keep in mind. So it's very unlikely that you will have 20 to 25 meter trees on top of a podium. It's very, you can do palms like that, you can do coconut trees like that. That's no problem. The other thing you want to know is that there are some trees like the gulmohar and the ficus tree, which have such strong roots that they have a tendency to break through RCC and brickwork. That happens. So usually you want to avoid those kind of trees, and those are trees you sort of learn about from time to time. The other thing is we tend to pick trees which will look good even if they were stunted to a height of 6 meters and 9 meters, and those are usually the size of trees I tend to pick for a podium, but that's not a rule. It's not a general rule. Maybe Sandeep can advise further. What is the largest tree you can pick for this for podium tops? Do you know, Sandeep?
I'm not sure, Arjun, because I think 6 meters and 9 meters are also like
really, really big,
the
really big.
Yeah.
I think the I mean, I would say 5 and 6 are the outer limit. Right?
Yeah, actually, yeah.
Unless it's a palm tree which can then grow however it wants.
Grow very tall, yeah. And a lot depends on the density of the wood also, because like
right.
prefer like a mimosops, like a mulch or something, because its wood itself is so heavy. That's probably why we find a lot of champa trees, like plumerias on top of podium slabs.
I guess you're right. Yeah.
Yeah. I also hate them. I mean, it's like it's become a norm everywhere. Champa.
They're everywhere. Yeah. Incidentally, there is a document that talks about the thickness of the tree species and its weight with reference to the thickness of its the girth, the circumference of its girth. The girth is the trunk. But it's not a well-known document. I've only found it by accident once, and it's difficult to convert it into kilonewtons per millimeter square or meter square, whatever that is. And it's not an exacted science as far as I can tell as of now.
Yeah, okay. That's interesting. I hadn't known of this. Yeah.
I know. Even when I was reading it, it was difficult to translate it for a structural consultant because he essentially says, yeah, okay, how much weight should I count? And I would say, I don't know, I'll have to do the calculation and come back to you. And then you give him a number in the end.
Even saturated soil also has a superbly high dead load. So yeah.
Yeah, I believe they count 1800 kilonewton. I think that's what someone had told me. And then lightweight soil only goes as low as 15 or 1600, something like that. But I don't fully recall this. And I don't understand it, more importantly, because theory of structures was a long time ago for me. And any other question? Okay. Sandeep, you want to end it here?
Yeah, we can. I mean, if there are no other questions, then probably we can, move to our personal channels. I think that was a very good presentation, Arjun. Extremely clear, and especially it was very nice that you had, kind of done those overlays. It was very easy for, I'm sure, the students also to kind of imagine how these layers kind of built up and, kind of get a project together. And it's almost like seeing the unseen, in a project. So that's great. Thank you very much for that. So I guess the students can log into their mentor channels. I've downloaded the attendance as well. Thank you.